Good day, esteemed colleague and members of the academic community and International Conference on Management, Education, and Social Science and Innovation. I am Muhammad Hanief Muzhaffar from University of Indonesia, and it is both an honor and a privilege to present our comprehensive work analysis on the convergence of biodiesel and hydrogen technologies for dual fuel marine engine system. Our scope of work hopefully seeks to integrate and critically evaluate current advancements, assess their technical and environmental implication, and also propose viable pathways for the adoption of cleaner, more sustainable marine propulsion technologies. As maritime trade continues to grow, so does its environmental footprint. Regulatory frameworks such as IMO MARPOL Annex Number 6 are increasingly strengthened, urging innovation in propulsion system. Biodiesel and hydrogen are such contenders. Each of them offers a unique environmental advantage. And this presentation explores how a dual fuel strategy that combines both can potentially revolutionize the decarbonization process for marine engines. For the research method, to ensure the academic rigor, our study implemented a three-tiered review process focusing on high-quality publication. The inclusion criteria were designed to filter only the most impactful and methodological sounds that works in dual fuel marine research. Our aim was to capture a holistic view of the technology current capabilities and future potential. For the fundamental of dual fuel engines. Dual fuel engines utilize two distinct but complementary fuels to optimize combustion performance. Diesel ensures robust ignition, while hydrogen promotes high temperature, low carbon combustion. The result is a flexible propulsion system that aligns with both performance and environmental benchmarks. For the biodiesel comes from animal fats or vegetable oils and then mixed with the process of transferification with the catalyst of methanol. Biodiesel, primarily in the form of fatty acid metal ester, is a drop-in replacement for fossil diesel in compression ignition engine. Its chemical structure and combustion properties enable easy integration into existing marine platform, making it a somewhat ideal pilot fuel in dual fuel system. Now for hydrogen represents the pinnacle of clean energy, offering zero CO2 emissions at the point of use. But however, the physical properties present considerable challenges, especially in the storage and transportation. These aspects must be addressed to harness its full potential in maritime contexts. For the engine performance and emissions metrics for biodiesel, the performance testing indicates that biodiesel influence on brake power is modest, but favorable. However, its elevated oxygen content intensify combustion temperature and often leading to increased NOx. Hydrogen, while eliminating carbon emissions, similarly necessitates NOx mitigation strategies. Now, for the optimization of dual fuel blends, experimental data suggests that the ideal dual fuel setup includes 15% hydrogen and 4% water under the full load condition. Water promotes micro explosions and enhancing combustion efficiency, while hydrogen expedites complete full oxidation. However, the exceeding optimal water content can hinder combustion due to increased fuel viscosity. Now, for the life cycle environmental assessment, the life cycle assessment provides a comprehensive lens through which fuel alternative can be evaluated. The comparative data clearly demonstrate the superior greenhouse gas performance of hydrogen and ammonia, especially when produced using renewable pathways. The key stage would be production, operation, and offline. Hydrogen and ammonia outperform heavy fuel oil in greenhouse gas footprint from well to pump, pump to hull, and hull to wake. Now, for the techno-economical viability, um, economic assessment reveal that while hydrogen remains relatively costly, biodiesel approach cost parity with fossil fuels in certain regions. Incentivizing green technologies through policy instrument is essential to foster broader, broader adoption. Now, for the infrastructure and logistic, infrastructure remains one of the biggest hurdles in hydrogen adoption for marine transport. Solutions such as modular electrolyzer and onboard reformers offer flexibility and potential cost reduction, enabling decentralized hydrogen availability. For the policy and regulation framework, regulatory alignment at both international and national levels is very vital. Instruments such as the IGF code and emissions trading schemes provide the policy scaffolding required to de-risk investment in alternative propulsion system. Now, for the future research roadmap for future researcher is that looking ahead, the focus must shift toward field validation and system level integration, from intelligence engine control system to full-scale trials. Future research should close the gap between laboratory innovation and operational readiness for using dual fuel engine, which is biodiesel and hydrogen. For the summary and conclusion, the integration of biodiesel and hydrogen represent not just as a transitional technology, but a potential transformative one. It aligns with global decarbonization targets and fosters a multidisciplinary approach involving engineering, economics, and policy. Thank you very much. We express our deepest thanks to University of Indonesia and Dr. Arif Budianto for their unwavering support in development of this research initiative. I appreciate your kind intention. I now welcome you for question and reflection. If there are such questions, feel free to connect via email for ongoing discussion for or potential collaboration. Thank you very much.